how do we score more than 90% marks and close to 100% in final exam? That is what you learn
I am Anil
when you
Kumar.
watch my videos.
Welcome to my
Since I
series
take
on
up
test
questions which are
preparation.
based on past test
We are looking
papers.
into
Here is
some
one for you.
examples from trigonometry. Now, these questions have been there in past test papers, and therefore, understanding their solution can help you get better marks. Here is a question based on modeling of daylight. On the nth day of a year, the number of hours of daylight in Vancouver is given by the function 4.2 sine 2 pi by 365 n minus 80 plus 12.76. How many hours of daylight should there be on March 2031st? On what dates throughout the year should there be 14 hours of daylight? You can always pause the video, answer the question, and then look into my suggestions. Now, part A is kind of clear. 31st March, we have to figure out how many days will it be since the beginning of the year, right? So we can count number of days. So let's count the days till 31st March. So we have 31 days in January plus 28 in February and then 31 in March, right? So add them all, so it comes to an average of 30, so 90 days. Correct? So in our equation, number of days n equals to 90. So how many hours of daylight? Just plug in 90 for n. So we can find the hours of daylight as 4.2 sine of 2 pi by 365. N is 90, so I will write 90 minus 10 plus 12.76, correct? And now you can calculate the value. So once you do this, you get a value of, let's calculate. So number of hours, the calculator should be in radians. While doing this calculation, we get 13.48 hours. So that is the answer for the first question. Now second part is, on what days throughout the year should there be 14 hours of daylight, right? So let's take it on a fresh page to answer this part. Well, in case you want to learn from me, you can always send an email at the given address or fill a form on our website, Global Math Institute. So let's take the solution of the second part, which is number of hours we need 14 hours. So in this equation, we can write 14 as equal to 4.2 sine of 2 pi by 365 n minus 80 plus 12.76. Rearrange, so we can write this as 4.2, let's write on this side, sine of 2 pi by 365 n minus 80 equals to 14 minus 12.76, correct? So sine of this angle 2 pi by 365 n minus 80 will be equal to, divide by 4.2, right? So we get 14 minus 12.76 divided by 4.2. Okay. I'll squeeze in the solution here itself. So now sine theta is equal to all this, right? So what is this theta equals to? So we get 2 pi over 365, the angle n minus 80 as equal to sine inverse of all this, which is 14 minus 12.76 over 4.2. Now, this is the tricky part, right? It is a positive value, 14 minus 12.76 over 4.2. Let's calculate. 12.76 divided by 4.2. So we get this as 31 over 105, right? So it's good to keep this as a fraction. You get the idea. And then find the sine inverse of this, correct? So when you find sine inverse of this, what do you get? You get an angle of 0.29997, right? So that's the angle which you get, correct? Now the idea here is that sine is positive in quadrant 1 and in quadrant 2, correct? You get the idea. So we get one value which is this one, positive value, which is 0.2997, almost 0.3. The other angle is how much? The other angle is pi minus this, right? So we have to find the other value, which is pi minus 0.2997, correct? So if I do that, shift pi minus this value, we get 2.841. So we get these two values, you get the idea. Now for these two values, we should be in a position to calculate n, right? So then only we'll get both the values for the daylight, right? And once we get these values, in that case, we can find the day of the year, correct? So those are the two values. So we have here two situations. One is 2 pi over 365 times n minus 80 is equal to 0.2997. So we can solve for this. And the other one is 2.841, right? So let's do the solution of each. So in the first case, let me rewrite here. 2 pi by 365 times n minus 80 equals to 0.2997. Right? Cross multiply. N minus 80 equals to 0.2997 times 365 over 2 pi. So let's do this. How much do we get? We get 17.41. So n is equals to 17.41 plus 80. So that gives me 97.41. Do you see that? So we get 97.41 days. So which day of the year will it be? We worked out that 31st March was 90th day, right? So it is 7 more days from 31st March, right? It is 7 more days from 31st March. So therefore, this will be which day? This will be April 7th day, right? You get the idea. So that is how we are going to do this calculation. So we found first day. Now the second day, let's calculate once again. Do the same calculations, right? So I like you to now pause the video. Do this calculation, right? So once again, 2 pi by 365 times n minus 80. This time it is equal to 2.841. 2.841, right? So n minus 80 is equal to 2.841 times 365 divided by 2 pi. Calculate. 2.841 times 365 divided by 2 divided by pi. You have to put 2 pi in brackets, right? Otherwise, you might make a mistake. You get the idea. Correct? So I get this value is 165. Well, so that's the number, whole number. So n is equals to 165 plus 80. So we'll add 80 to this to find the nth day, which comes to 245. It is 0.0 something, which I have ignored. So which is the 245th day? So that is what now you have to calculate. So do this calculation and figure out which is this day, right? So you can go by months. You go 90 days by March, and then April, May, June, keep on adding the days, and then you'll get your answer, which comes to September, right? 2nd. So on these 2 days, you will find that the temperature is 14 hours a day based on the formula given to us. You get the idea. So I hope you have understood this calculation. It's kind of very important to understand these calculations. I kept the numbers without simplifying so that you could solve any question based on such formula. You know how to rearrange and get your answer. I hope it makes sense. Feel free to write your comment, share your views. In case you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.